engines. First, we'll review the basics of how an engine works and some basic engine terminology. An internal combustion engine needs air and fuel to function. The more efficiently an engine breathes, the more efficiently it will produce power. Now we'll look at the basic components of an engine. The main components of the engine are the engine block and cylinder head. The internal components of an engine include cylinders, the crankshaft, connecting rods, pistons, spark plugs, fuel injectors, intake and exhaust valves, camshafts, and a timing chain or belt. Power is produced in the engine by the four-stroke process. As the piston moves on its first downward stroke, the intake valve opens to allow a mixture of air and fuel to fill the combustion chamber. This is called the intake stroke. Next, the intake valve closes and the piston moves on an upward stroke that compresses the air-fuel mixture. The compression of the air-fuel mixture will make it combust with greater force than if it were uncompressed. This is called the compression stroke. Third, the spark plug ignites the air-fuel mixture, causing it to burn explosively, which forces the piston into another downward stroke. This is called the power stroke. The fourth stroke is the exhaust stroke. As the piston begins its second upward stroke, the exhaust valve opens and the burned air-fuel mixture is forced out of the combustion chamber through the exhaust valves. Two terms you may be asked to explain to customers are the engine's compression ratio and displacement. Compression ratio is the ratio between the total volume of a combustion chamber and cylinder when the piston is at the bottom of its stroke and when the piston is at the top of its stroke. In this example, the compression ratio is 10:1. Higher compression ratios produce more power but require higher octane fuel than engines with lower compression ratios. Engine displacement is how the internal size of an engine is described. It's measured as the cylinder bore times the length of the piston stroke. This is multiplied by the total number of cylinders and is usually expressed in liters or cubic centimeters. For example, a 2.4-liter four-cylinder engine has a total displacement when adding together all four cylinders of 2.4 liters. The number of valves that engines have varies. Older engines tend to have one intake and one exhaust valve. Some engines have two intake and one exhaust valve. Most high-performance engines use two intake and two exhaust valves. The opening and closing of the valves is performed by the camshaft. Some engines use one camshaft with rocker arms and/or push rods actuating all of the valves. If the camshaft is above the valves, it's called a single overhead camshaft or SOHC engine. More than four cylinders typically have the cylinders arranged in a V configuration. All Toyota 6- and 8-cylinder engines are V-type engines. Now let's look at technologies Toyota uses in its engines to enhance
a clutch to transmit power produced by the engine to the gearbox. The vast majority of cars and motorcycles rely on dry friction clutches, which will be explained in this animation. One of its components is the flywheel. The flywheel is connected to the engine through the crankshaft. The flywheel features external teeth that are used to start the engine of the vehicle. When the car key is turned, the engine is started with the help of a pinion and the battery. After a small amount of time, the engine runs on fuel. The flywheel is equipped with a friction surface. The clutch disc has friction surfaces too. When the friction surface of the flywheel and the friction surface of the clutch disc are brought into contact with each other, the clutch disc rotates. The clutch disc is made of several components, of which the important ones are the hub, which is riveted to the disc with a cover plate, and the friction material installed on both sides. In the past, friction material was made of asbestos and other harmful substances. Today, friction surfaces are made of ceramics and substances that provide a high coefficient of friction. In general, cars for daily use are equipped with clutches that feature springs to damper shatter, to achieve an easy operation and to reduce the impact to the gearbox at the engagement. The clutch disc is connected to the gearbox through the gearbox shaft. Consequently, the wheels of the vehicle only rotate when the flywheel is in contact with the clutch disc. The pressure plate is needed for engaging and disengaging the clutch disc. The pressure plate is riveted to the flywheel. As a result, the pressure plate rotates when the flywheel rotates. Let's take a closer look in order to see what happens in this important component. A clutch release bearing is positioned in front of a diaphragm spring. When the release bearing is pushed into the spring, the inner portion of the spring is moved in the direction of the clutch disc, whereas the other portion of the spring is moved in the other direction. Consequently, the clutch is disengaged because the pressure disc is mounted in a flexible manner to the casing. So, the clutch disc can be locked between the flywheel and the pressure plate when the release bearing is released, and it can be released when the bearing is pushed into the diaphragm spring. The mechanical energy produced by the engine is transmitted to the gearbox when the clutch release bearing is released and the clutch disc is engaged.